Consider the curve given by x squared plus 4y squared equals 7 plus 3xy. Part A, show that the derivative dy over dx is equal to all that stuff. Let's start there. So, the derivative of x squared is 2x. The derivative of 4y squared, well, y is stuff. So the derivative of 4 stuff squared is 8 stuff times the derivative of the stuff. And this is equal to the derivative of 7, which is 0, plus 3 times quantity, the derivative of xy. Now for xy, we have to use product rule. Product rule says that we take the derivative of the first, the derivative of x is 1, times the second is y, plus the first, x, times the derivative of the second, well, the derivative of y is dy dx. Let's distribute the 3. Here we have 2x plus 8y dy dx is equal to 3y plus 3x dy dx. Let's get our dy dx's on one side. So we have 8y dy over dx minus 3x dy over dx. And now we'll move our 2x to the right hand side. So we have 3y minus 2x. And of course we can now factor out a dy dx and divide by 8y minus 3x, yielding dy over dx is equal to 3y minus 2x over 8y minus 3x. Now let's double check our answer. 3y minus 2x over 8y minus 3x. Perfect. Part A done. Now let's focus on part B. Show that there's a point P with x coordinate 3 at which the line tangent to the curve at P is horizontal. Find the y coordinate of P. Now, if our tangent line is horizontal, that means that the derivative is equal to 0. Since a horizontal tangent line has slope 0, and the derivative is the slope of the tangent line. So let's set dy over dx equal to 0. Here we have 3y minus 2x over 8y minus 3x, and this is all going to be equal to 0. Now, a fraction is only 0 when the numerator is equal to 0. So this implies that 3y minus 2x has to be equal to 0. And let's solve for either y or x. Neither would be easier up here, so it doesn't really matter which one we solve for. So let's do 3y is equal to 2x. That means that y is equal to 2/3 x. Well, we know that the tangent line is horizontal when y is equal to 2/3x. Let's plug 2/3x back into y in our original equation and see what happens. So here we have x squared plus 4y squared, that's 4 times 2/3 x squared, and this is equal to 7 plus 3 times x times y, and that's 2/3 x. Two-thirds x squared, that's 4/9x squared, times 4 is 16/9x squared. Here we have 7 plus 3x times 2x over 3. The 3's cancel out, and we have 2x squared on this side. Well, let's see here. We can subtract 2, which we get negative x squared plus 16/9x squared equals 7. Negative x squared is the same thing as negative 9/9. plus 16 over 9 is 7 over 9. X squared is equal to 7. Now we can multiply both sides by 9 over 7, and we get x squared is equal to 9, which implies that x is equal to plus or minus 3. Let's go back and put this all into context. What we did here is we set the derivative equal to 0 because that's where we have horizontal tangent lines. Now, the derivative is equal to 0 when y is equal to 2/3 x. We then substituted 2 over 3x in for y in the original curve, and we solved for x. So these are the two x values where we have a horizontal tangent line. There's one at x equals 3 and one at x equals negative 3. Now, the next part of this says find the y-coordinate of P. We have already shown that there is an x-coordinate 3 where there is a horizontal tangent line. Boom, here's 3, we got it. But now we need the y value. Of course, we know that when we have a horizontal tangent line, y is equal to 2 over 3x. That was our condition. So we can just plug 3 back into x, and 2/3 of 3 is 2. Which means that there is a horizontal tangent line at 3, 2. Why? Because we have a horizontal tangent line when y equals 2/3 x. We know that x equals 3, which means that y has to equal 2. And there it is. There's the whole thing.